everyone. My name is Jamika, and I'm on the academic team here at Zern. Zern is a nonprofit founded on the belief that every kid is a math kid, and our work is focused on supporting teachers with research-backed curriculum and digital lessons that can help catch kids up and move them forward in their math learning. As a former teacher, I know that is often a true aspiration, but I promise you it is possible, and I'm excited to dig into some math examples to see how. So a little note on logistics. As the demands of our time have never been greater, this webinar will keep to about 30 minutes long. Our team is monitoring the chat on Zoom, so please post if you have questions. And of course, you're welcome to share any of this content on Twitter or your PLN. Please tag us at ZernEd, and you can use our hashtag ZernLive. So with that, let's dig in. So first, when you think of unfinished learning or even unfinished teaching, what word or phrase comes to mind? I would ask that you jot down a reflection, and please feel free to share it in the chat. See, gaps, absolutely. The idea of not yet, I love that. Students who have gaps are only parts of their learning, opportunity. Some learn faster than others. I agree. Ooh, exposure, but not mastery. Potential, love that also. For me, what comes to mind might be a little bit unexpected. I and others on the Zern team have learned from incredible teachers all over the country, and I've come to a different way of thinking about unfinished learning. So when I think about unfinished learning, I think about big ideas and dense connections. If our kids don't experience math as a few big ideas, they could learn to see math as a bunch of small but equally important concepts kind of stacked together in a random order. And when we experience math this way, those ideas are not sticky and the connections between the ideas are fragile. You can sort of think of it like a house of cards that'll fall with any new idea. But when we think of and experience math as a few big ideas, such as whole numbers and operations, fractions and decimals, measurement, that kind of spiral in and out and keep coming back, we build really dense connections between these ideas, which allow us to tackle any problem. And when we have dense connections between a few big ideas, there's always a way in, and we can complete unfinished learning while we learn new content. So you may wonder, how can Zern support you with building dense connections that help catch kids up and move them forward? How about we jump into some math first to see it firsthand? So as you know, grade 3 is a seminal math year. Students have a fresh start with multiplication and division of whole numbers in 100 and get their first deep exposure to fractions as numbers, which is the core foundation of ideas they need to access math in later grades. So let's consider the start of first grade, which is the first time students learn multiplication and division. This is what I think of as a fresh start, work that is a new entry point into a big idea of math. Multiplication and division is a new big idea that kind of kicks off in 3rd grade. So how about we look at how unfinished learning can be grappled during this instruction? So where we first encounter partitive division, let's look at a problem from the beginning of 3rd grade. This is the beginning of the work in 3 to 5 to deeply understand division, which is a major focus that extends from whole numbers in grade 3 all the way to fractions in grade 5. Consider the problem from the beginning of 3rd grade. 7 times blank equals 21. 21 divided by 7 equals blank. I would ask that you take a moment to reflect on this question. What might your students find challenging about this problem? If your students have unfinished learning from second grade, in addition to subtraction, it may feel foolish to bring in new operations. I can remember that it's always tempting to go back to grade 2 and spend several weeks covering critical objectives from second grade content, which is multi-digit addition and subtraction problems within 100, word problems, composition and decomposition strategies, before then returning back to the third grade multiplication and division work. But what if we explored an alternative? Now, let's look at a similar problem, still exploring partitive division presented with context. Ms. Alves puts 21 papers in 7 piles. How many papers are in each pile? Take a moment to reflect on this problem. Compared to the last, what do you notice and what do you wonder? Feel free to share your reflections in the chat. Grounded in real life examples, which help students visualize. Maybe more complex for students. It's relatable to real life. I agree, vocabulary is also very huge in math. Provides context, absolutely. I love that now students are able to use a real life story and can draw from that. So you guys nailed it right on the head. Here, the context of this problem acts like a friendly on-ramp. By adding this context, the problem helps students better visualize the math. So let's do that. We're gonna first visualize the problem. So I'm gonna start by drawing a circle to represent a piece of paper. There are 7 piles, so I'll put 1 paper in each of the 7 piles at the top of the array and continue to draw out all 21 papers. This array helps students make sense of the math. At this point, students could solve by simply counting. This array helps me see the number of groups, 7, and lets me determine the size of the groups, 3. So there are 3 papers in each pile. This visual representation lays a conceptual foundation for multiplication and division. And from here, these visualizations will offer the opportunity for students to generalize their learning. In the tape diagram, kids can see items as groups rather than individual items or 1 unit. That's a unit of 3 that I can count by. That will help them throughout their 3rd grade learning and into 4th and 5th grade learning. Eventually, we'll see that here we count by 3s, but we could count by 4ths and count 7/4 instead. So the idea of the context and concrete representation is so important. It gives everyone a way into the math, and I don't have to be able to skip count by 7s or 3s. I don't have to understand repeated addition. There are no prerequisite skills or nothing I need to master from 2nd grade. Instead, we're able to visualize equal groups and arrays and use context to help us make sense of the math. We can actually count to solve, which is a 1st grade skill. We can then bring in consistent skip counting strategies and continue to use array models to help students naturally relate multiplication and division and help them become fluent with these operations. And what's so magical about math is that because math is just a few big ideas with really dense connections, there's always a way in. Here, we can complete unfinished learning and move forward at the same time. And doing so relies on context and visualizations. The representations that we introduce are tools that students can almost always fall back on to help them make sense of more complicated situations. We always start with the diagrams that are most closely aligned to how students naturally reason about and represent the stories to themselves. And then we can scaffold students up to more and more abstract and powerful representations. These concrete or visual representations, like this array model, and then ultimately the tape diagram, help students see structure, make sense, and have something to fall back on besides a list of steps when they're stuck, or to get started with when they first see a tough problem. Now, I wanted to show you how Zern can help you with supporting this deep conceptual understanding. Zern is a math platform with digital math lessons for every objective of K-8 math. Our digital lessons are designed for students to complete at their own pace, each with concept exploration and application work. Our digital lessons build conceptual understanding alongside your instruction. You can kind of think of it as a double dip in a way, meant to complement the instruction that you're already doing. How about we explore a similar problem in the context of a digital lesson? As we work through the lesson, feel free to jot down reflections to these questions. How was this similar to the paper and pencil math work we just did? How was it different? How might those differences deepen student learning? And as always, feel free to share your reflections in the chat as we go.
I want to distribute 18 tangerines equally into 6 bowls. How many tangerines will be in each bowl? First, draw an array to represent 18 tangerines equally divided between 6 bowls.
So right off the bat, we start with the problem context, leveraging the concrete representation of tangerines into bowls to serve as an entry point into the problem, recognizing that students are most likely still developing their own understanding of partitive division. We then bring in an interactive digital manipulative to help students pictorially represent the problem, like I did with my circles on paper. Let's build the array model.
Let's create a tape diagram from this array. I'll draw a rectangle around the tangerines like this. This time, I'll label the hole 18 tangerines here. I'll draw lines between each column to show the groups. Each boxed column represents 1 unit or 1 bowl. There are 6 bowls. I'll write that here. We're trying to find how many tangerines are in each bowl, so that's our unknown. Write a multiplication and division equation to solve.
So moving students from the actual bowl of tangerines to the digital representation of the array, and now to the tape diagram is really significant here. It is an intentional move to help students see the value in the array model and tape diagram as powerful tools to fall back on as they encounter more challenging problems with division. Notice how we still have the visual representation for students to reference as they build out the multiplication and division equations. So I'll go ahead and build my multiplication equation. And then I can build the division equation. Setting up these equations allows me to solve. I can see that 6 times 3 equals 18, and 18 divided by 6 equals 3.
6 groups times our unknown, the number of tangerines in each bowl, equals 18 total tangerines. And 18 total tangerines divided into 6 groups equals our unknown. There are 3 tangerines in each group, so that's our unknown.
That's right. Complete the answer sentence.
So I'll complete the answer sentence. There are 3 tangerines in each bowl, which brings students back to the context of the problem. Now, let's jump slightly ahead and look at one more problem.
This array represents our problem. 2 discs in each column for the $2 each week that Kayla saves, and 16 total dollars. Let's create a tape diagram from our array. I'll draw a rectangle around the hole like this. Keep going. Which tape diagram is partitioned so that there are $2 in each unit?
So notice again how we bring in the models to help students visualize the problem, starting first with the array model and showing the connection to the tape diagram as a more advanced model to relate multiplication and division. So now, how is this similar from the paper and pencil math work? And how is it different? And how might those differences deepen a kid's understanding? Let's take a moment to see what reflections we have in the chat, and I'll share some out. Yes, right away, I see visuals. Mhm. Self-paced, interactive, yep. Yeah, the contextual problems do make sense. It helps students make sense of the math and get the procedures. There's a movement from concrete to abstract. Of course, using technology is always fun. Yes, we can see that it's the same visual representations and allows for some immediate feedback. The combination of interactive models with a conceptual understanding, right? They're able to see a picture and kind of visualize it in their heads to solve. So again, we see the strategic use of context and visualization as two key strategies to support acceleration. This idea of catching up and moving forward at the same time. Now, let's explore another division problem, this time from 5th grade. 5th grade covers vital fractions and decimal operations work. It allows students to extend their understanding of multiplication and division of whole numbers to multiply and divide fractions. So how about we take a look at this word problem from the 4th unit of 5th grade, where students must lean heavily on their understanding of whole number operations as they are introduced to division of fractions for the first time. So let's look at this problem. Nolan has 1/3 pan of brownies. He wants to share his brownies with 3 friends. What fraction of a whole pan will each friend get? I'd ask that you reflect for a moment. How might your students solve this problem? Where do you think they might get stuck? So I want to jump into a Zern digital lesson that offers a similar problem to see how Zern can support your students with deep conceptual understanding. As we work through the lesson, feel free to jot down reflections to these questions. How is this different from the paper and pencil math work you might do with your students? And how might it deepen their learning? As always, feel free to add your reflections in the chat as we go along.
Let's take a closer look at these division sentences. Did you notice a pattern in our quotients? Each time we started with a smaller whole, there was less bread to share, so the quotients became smaller. Let's do another one. 1/5 divided by 2. If you get stuck, you can imagine this as sharing 1/5 of a loaf of bread between 2 people. Partition and shade the tape diagram to show 1/5.
Notice how we're connecting to a familiar context, a loaf of bread problem. The context really helps students make sense of the math. And this is the key idea of the on-ramp. If we use an unfamiliar context or no context at all, it really robs students of their working memory needed to focus on the new content itself. So rather than moving straight to the solving the expression, students draw a tape diagram, helping all students build deep understanding of fraction division and relate it back to the work they did in third grade with modeling fraction equivalent. All right, let's partition the tape diagram into 5 equal parts and shade the unit fraction 1/5.
Let's divide 1/5 by 2 on the tape diagram. Partition each unit on the tape diagram into 2 equal parts.
Here, we are scaffolding the work for students as they continue to look for a pattern that emerges when dividing a unit fraction by a whole number.
Now, double shade the tape diagram to show 1/5 divided by 2.
So how many tenths are in 1/5? Here, color supports help all students as they learn fraction division. I see 2/10 in 1/5. And looking at the double shaded region, see that 2/10 divided by 2 equals 1/10. So 1/5 divided by 2, connecting all of our representations, would give us 1/10.
There are 2/10 in 1/5. 2/10 divided by 2 equals 1/10. We can see that here on the tape diagram. So 1/5 divided by 2 equals 1/10.
So at this point, when students are asked to complete the more abstract step of writing the division equation to represent the problem, the lesson prompts them to use their pictorial representation for support. And again, moving students through the mathematics back to the original problem to answer the question. You can see how digital lesson makes the work accessible through a thoughtful, scaffolded progression of learning that leverages the language of division and models that was developed in grade 3. And what's really unique about Zern is that our digital lessons build conceptual understanding right alongside your instruction. You can think of it as a double dip in a way. I also hear from lots of teachers that use the digital lessons on their own as a quick inspiration for strategies to bring into instruction to scaffold learning. So if we take a step back and come back to look at these 2 problems, across the 3 to 5 grade band, we can generalize a few strategies that we use at Zern to support kids with catching up and moving forward. Within every grade level digital lesson, we offer supportive on-ramps into grade level learning. This could be problem context or concrete and pictorial representations that both activate and teach ideas from prior grades. All along, helping kids make sense of new concepts by anchoring to concrete ideas they already know or intuitively make sense to them. I want to point out that on-ramps alone may not be enough. As your kids may work through grade level concepts, a embedded daily diagnostic assesses each student's understanding and automatically launches a boost exactly when kids need it, with supportive and scaffolds they need from prior grades or even prior units. We know that all kids don't master every concept from prior grades, and so our materials don't assume that they do. And this is one of the most important parts of Zern compared to other independent digital work and intervention programs. We are continually assessing, diagnosing, and giving kids the boost they need built into their grade level learning. And finally, some kids will still need more than these tier 1 interventions. And that's when additional foundational support coherently connected to core instruction comes in. Zern offers intervention lesson recommendations that are based on data from over 11 billion problems kids have completed on Zern, where they struggle, and what foundational content can precisely support them. Our digital lessons show learning acceleration, this idea of catching kids up and moving them forward in action. Learning acceleration begins with grade level learning, and when those learning gaps arise, students engage in just-in-time foundational support connected to the grade level content they're already learning. And here at Zern, as a nonprofit, access to our content is completely free. And with that, let me go ahead and take a few of the questions that I see in the chat. All right, one of the questions I see is, what happens if students struggle in the independent digital lesson? Well, if a student makes a mistake in any part of the digital lesson, they receive precise in-the-moment feedback. If they continue to struggle, then Zern will launch a differentiated support that brings in those connected foundational concepts right into the context of their grade level learning. And if students continue to struggle on Zern and productive struggle turns into unproductive struggle, Zern's platform alerts teachers in real time, and that's when targeted foundational lessons can come in that are directly connected to the grade level concepts that your students are learning with you. Another question I see. Oh, can you explain learning acceleration in simple terms? Sure. One explanation that I love for learning acceleration kind of borrows from a 2021 piece in Education Weekly. The article said, one way to grasp the difference between acceleration and remediation is to think of the previously on segments that play before a new episode of your favorite TV drama. Those quick catch-ups help you understand enough about the characters and plot of the show to be able to follow along with the upcoming episode. But a viewer wouldn't nearly get as much of the backstory as they would if they say binge watch the past few seasons. And in a similar way, acceleration gives students the background information they'll need to access a particular grade level concept, as opposed to trying to catch them up on all the information they may have missed from a previous year. That way, students will still stay on grade level, reviewing only the concepts that are most important to learning what comes next. I think we have time for one more question. What grade levels are included in Zern? Our daily digital lessons and teaching materials are currently available for all grades K through 6. We also just released a few missions of our grade 7 and our grade 8. And Zern is completely free for teachers and will always be. And with that, I want to take some time to thank you so much for your time today. I'm so excited to support our community and help you make instructional choices as we head back to the classroom this fall. We hope our digital lessons can offer you the complement you need to tackle this year. And I hope you'll stay connected with us on social media. You can also join our Facebook support community to share ideas and inspiration with other lifelong learners. Thank you so much, and I hope you have a great day.